All right, I think we're good. Hello everyone. I will do the usual kind of 5 minute wait before diving into this week's office hours, kind of guess the final office hour of week four, um, or maybe the first of week five, depending on how you view it. But yeah, I am. Hopefully this resolution is a little bit better. I'm still on my laptop, but I do have a second monitor now, and I do have my old microphone, so maybe the audio is a tiny bit better as well. But let me just type in the chat now. Yeah, so if there's no questions, I'll do the kind of typical, very, very high level walkthrough of the kind of homework and some potential ways to think about it, like breaking it down sentence by sentence and saying what that might translate to, just in case you're kind of stuck. But again, ideally answering any questions that do pop up. Um, yeah, and then maybe talking about some of the stuff next week. The homework is really close. I'm hopefully going to finish it after these office hours and get that out. And for the next week, there is no OLI quiz. Actually, for these last 2 weeks, there's no OLI quiz. But there will be something in its place, and so there will be an announcement on that. But you'll be able to find it in Canvas. So instead of like submitting a screenshot, you're almost certainly going to be submitting a tiny Python file. Um, and I think in particular for this week, the lab and the quiz are going to be a little more handholdy, maybe, or like smaller. Um, So like we're covering this concept of recursion for next week, um, and which I don't have pulled up, but it's the next one. And so I'll just probably get two kind of quick functions dealing with recursion um, for that, and then there's kind of some other stuff I want to show you that is not an OLI. So I'll kind of give like a worked example for that. So it'll a little different style in the sense that you're not going to be answering questions on a quiz, but kind of just doing something else. The recursion part for next week is also kind of small, and there's like no coding in it. There's still questions, but they don't actually get you to type out any code that demonstrates this concept of recursion, right? And so that's what I want to target with like the lab to show you it. And with the quiz, again, I want you to kind of learn this other concept that's not an OLI, but hopefully not too hard. So I'm gonna finish up the worked example kind of thing I have on that and provide um, another link to like some documentation on it. But I think it'll really help in PUI, the follow-up course. Um, so I want to, for these last 2 weeks, have the kind of labs and quizzes in particular, kind of tailored toward things that I think will be super helpful when you're doing the follow-up course PUI, and then have the homeworks continue to focus on kind of these concepts that we've been covering, um, and trying to get to like kind of bigger and bigger code bases in a way. So like for this homework in particular, for homework four, right, there's this coin flip function, which isn't necessarily big, but it is like kind of four functions, right, that I talked about, how like this one will call the previous one, and so on and so forth. So the homework for this coming week will kind of make use of similar things, but it'll be a little more than just like, uh, you know, return randomly heads or tails, for instance. So, but we're almost at the 5 minute mark. Also, in the announcement, which I'll be making probably tonight or very early tomorrow, the office hours will again be slightly shifted. So last week I had a shift um, Tuesday to Wednesday, and Thursday got pushed back by like 2 hours, I think it was. And something very similar will happen for this week. I'll try. I just got the schedule for where I'll be going for this conference this coming week. Um, and I'll try to make them line up to the same as last week's. So even though they're shifted, at least there's like some congruency, right? Because then it'll just be shifted the same as last week. So hopefully on that, uh, it'll hopefully be like that, yeah. But again, I'll just make an announcement like this, and they'll be recorded either way. And then Sundays will likely be the same as well, which I think is maybe, I don't know. I mean, the lab one's important, but I feel like I get the most kind of questions Sunday because it's like, 14 hours before the homework's due or whatever. But all right, I'm gonna dive in. So let me type this. I think that's how it all works. All right, let's pull this up, and I think yep. So this is the provided Python file on the homework assignment right here. Sometimes it opens, sometimes it doesn't. There we go. So that's just what I have pulled up here. And let's get these instructions. So I think in the last, or maybe the past two vids, I kind of just talked about the reasoning of kind of giving these functions for the homework. And now I'll kind of just walk through like the thinking process that you can maybe take up on them. But again, the whole idea is to kind of combine conditionals and loops. Maybe do a little kind of sorting stuff that we touched on a little bit, right, with like insertion sort. Yeah, and using functions to call other functions, which we had dabbled with a little bit, but I think kind of coin flip helps to kind of sell that a little bit more. So let me type one more thing. To ask questions. All right, so for find median, which we have here, so we can see it's going to return, an integer, more than likely, right? Because I just had this placeholder 5 here. So this function takes in a list of ints and should return the median of the input list. So a list of integers, I'll know. So, list could be, let's make it easy, 1, 2, 3, right? It doesn't say anything about the size or nothing at that point. So just do a basic list of ints, 1, 2, 3. The median of list is the very middle element of the list when the list is sorted. And again, you could just median in case you forgot what median is or just didn't know, right? Nice examples. But also it kind of tells you right here, very middle element of a list when the list is sorted. So, there's kind of a key kind of word right there that we should maybe think about. So list should be sorted for this. When the list has an even length, right? Because in the middle is kind of shared, like between here. Sorry, trackpad struggles 2 and 3 right here. The median is the average of the two middle inputs, and that the list is empty. Then this function should return none. So let's go back in here. So like, when odd, or the two middle, like average, when even. This should be sorted, right. And then the last bit of if the list is empty, it should return none. So, we've kind of dealt with empty stuff before, so maybe I'll just go ahead and do that. So if length of the list, 0, return none. So then I don't even need to really comment that part. That's just length checks length of the list. If the list is empty, it's going to have a length of 0. So, I already kind of know that. So I'll just return none. So then, yeah, I can kind of work off these 3 comments. Right here. So looks like I could have a list of smaller size, but I like the 3 case right here. So I need to find the middle element when odd. So if, I take the very middle element when it's odd, but then I take the 2 middles and average them when it's even, I'll kind of need to check for that. And so you can check if like, Oh, and odd in the terms of like when the length, right, is odd, not just like when a list is odd. But so, to kind of determine these two different paths, maybe it'll lend itself to a conditional, kind of like that's when X do something, when Y do something, right? So maybe that's a way I might want to approach this. I think a key part is like the list probably will need to be sorted, right? Because if you kind of look at this example right here, right, 50, 30, 10, 20, it is an odd linked list of 5 elements. If I just took the middle, in this case, it's 10. But that's not the answer, right? Because we need to sort the list, which would be 10, 20, 30, 40, 50, and the middle element would be 30. So I definitely would want to handle a case like that. And we kind of got that from here when the list is sorted. So maybe I'll need to find a way to sort my list. Um, there's a bunch of ways you could do that. I think you even get code for it in here if you wanted to include it. But again, there's perhaps a simpler way you could call something to sort a list. And then maybe I'll need to do my checks right here on odd length or even length once that's done to determine if I need to just go ahead and grab the middle element and return it or do this whole average thing. And yeah, that's kind of median for a fine median. Moving on to popular name. Trying to get better at like giving timestamps for people that watch it after, so. All right. So popular name. All right, now it looks like it's returning a list of strings. So let's kind of read it and break it down. This function takes in a list of strings. Okay, so it looks like it takes in and returns kind of list of strings, representing a set of names such as Cindy, Yang, Thomas, Felicia, and Yang. So I'm gonna go up here and say there we go. Just throw some names in there. They don't have to be names. It could be whatever, right? So all right, we have another sample input right there. This function should return the most common name, or string, right? Found in the list. So for this previous list, it would be Yang. So we look here, Cindy goes once, Yang is at this index and this last one. So it's 2 times it occurs, Thomas once and Felicia once. So okay, right, makes sense then. Yang's the most popular name in the list because it occurs more than any other name. Right. So then I might go back here. For like most occurring string. So I need to check this list, right, for the most occurring string, aka name. Based on that, if there's more than one name that occurs the most, such as 2 names both occurring twice, then you should return a list of both names. Okay. So then I can go back here. Like if there's a tie, return both / all. Right? Because like if I guess we get a list of these twice or whatever, we'd want to just return this 3 or even just once because there's a 3-way tie. List of both names. If the input list is empty, return none. All right, so again, we've kind of dealt with empty before, so let's just go up here. And since it's almost as easy to comment about it as it is to just write it, there we go. Return none. Finally, be sure to treat the names case sensitively so that Raksha and Raksha count as different names. Below are some examples. So like, all right, case sensitive names. So I'll need to know they're different. We did do with some string input for I think the last homework or lab that we maybe made something lowercase to make it easier for the vowel count kind of thing. But maybe this case we don't want to do that, right? Since we do want these two things to be different names. So don't get tripped up on that. And below are some examples. So yeah, in this case, Chris, Tasia, Morgan got passed in, And since there's a three-way tie for the most current one, it returned just all three of them. Then here's kind of our example, but Cindy got replaced with Tom again. So then there's a two-way tie as Tom occurs twice, Yang occurs twice, and Felicia once, so it returns Tom and Yang. Here's another example where Tom's capitalized here, but not here, and Yang occurs twice with the same capitalization, so just Yang gets returned, right? And then, the other case. So, okay, think I understand that, right? So if I get a list of names, then I probably will want to like iterate through the names, right? Iterate through this list of names, because I mean, I'm maybe gonna want to like check each name and stuff. And I'm gonna have a list to return that might have multiple items, so then maybe I'll go ahead and have you know, some list variable here of like popular names. So let's do like popular name list that I want to return. So iterate through a list of that, and then oh, popular. I spelled it wrong on both. Popular. Let's just go. Let's go with popular. Um, so let's. Right. So if I iterate through the names of the list, and then I'll want to somehow like check for most occurring ones. Then if they are the most occurring ones or one, then I'll maybe want to add it. I add the name. Um, but obviously checking for the most occurring ones is maybe harder to do than just to write this comment. If you're definitely going to want to iterate through the names, there's kind of different ways you could see how much it occurs. So if I'm iterating through a name, maybe I set a variable to like name is going to be whatever I'm iterating through, right? I, so like, for I in this list. Then maybe I get this name, and then maybe somehow I call it on like, how many times does name occur in the past in list, right? And so maybe there's something I can call on my list to check for this. I say maybe, I mean, there definitely is. So, there's ways you could iterate through this several times, right? You can iterate through the list, and then for each kind of word, iterate again and keep this kind of count of how much this name's occurring. You can iterate through like once and then call something on the list maybe to check how much it occurs. Um, so yeah, I don't want to dive too much in here, but I would say there's maybe two kind of ways that readily come to my mind about it. But as I always say in office hours and stuff, that there's many ways to solve programs, but with every way, you're almost going to want to iterate through this list. Maybe keep a counting variable, right? Of like how much something occurs. So, if we've seen the name before, maybe increment this count occurrence variable, right? Equals, and then, maybe keep a running track of that and try to see, hey, this is greater than any other count occurrence we've encountered before, so it's the most popular. So add that to a list or, do something else with it. So don't want to dive too further into that one, but I think that should kind of give a little framing at least. Add it anyways, So, there's like the case where, oh, it becomes like the new popular one, right? Like, oh, this name occurs three times and the previous ones were just two times. Uh, so you're gonna want to like, maybe delete your popular name list if that happens, right? Because you could have a list like, let's just do this. Oop, cannot type on this laptop. So if we have like 1, 1, 2, 2, 3, 3, and 3. So, maybe I'm iterating this list and I'm like, okay, well, 1 occurs twice. it's all we've seen so far. Let's go ahead and add it to this popular name list. Then I continue my iteration. Okay, well, 2 has occurred twice. Let's also add it to the popular name list, right? We have a tie right now. Then I go through 3. I'm like, no, it's only 1, 3, so it's not. I get 2 3s. I'm like, oh, okay, look, now we're tied again. Let's add 3 to this popular name list, so now we just have 1, 2, and 3. And then, I hit this third 3, and I'm like, oh, okay, well, now this becomes the new popular name, right? Because so far, at least, we've done 1 and 2 just twice. So maybe I should dump them out. Um, but then you also need to be careful as well of having a case like that if you're just kind of doing it like in step. Um, so maybe there's something else you can do to help with that. But all right, we'll move on to adding pairs. Pretty sure it's onto instead of onto with one word. I'm really bad at grammar, so please forgive me. Adding pairs is one where it's can be almost like cheesable, where it's like you can make it really short and not have to write a lot of code if you do something. Um, but there's also another way that's maybe a little more code and less efficient. But that's kind of why I had this function in here. So off the bat, you can see returns int. Looks like we returned a number, an integer value, and based on this LST parameter, I'm assuming we take in yet another list. So let's look. This function takes in a single parameter, LST, corresponding to a list of ints. All right. Personally, when I see a list of ints or something, I like to just go ahead and have that placeholder of 1, 2, 3. It should return the largest sum of any two numbers in this list, or return none if the list contains one or less. So, I'm going to go ahead, I hear that return one or less, so if my list of length is less than 2, let's return none, right? Because if it's 0 or if it has one element, it'll be less than 2. But that first part was talking about it should return the largest sum of any two numbers in this list. So I want the kind of biggest number I can make out of two numbers in the list, is what that's telling me. So maybe I'm still confused. Let's look here. 2, 2 are passed in. It's 4. 1 through 9's here. The answer is 17. So 8 plus 9, the two largest are these, yeah, the two biggest numbers also make the largest sum when added. So, okay, 17. So that does seem right. So, in my case, this would be, return 5, right? Because 2 plus 3. For instance, with adding pairs, 5, 8, 4, 7, it should return 17. Since that's the largest sum of two numbers in the list I can make, I think that was supposed to be a 15 here. I think I just actually copied it from there. Did someone point that? I think actually maybe someone pointed that on Piazza. But yeah, it should be 15. I'm not sure how you would get 17 out of here. I guess if there was a 10. Well, no, still not, because then that'd be 8. So you need the 9. Yeah. Oh, here we go. For popular names, should our code assume that a name will not appear more than twice in a list? No, you can assume a name will appear, I guess, an infinite amount of times. Yeah, I guess technically these examples aren't showing that case, but if your code can handle like 2, I guess ideally you should be able to handle the case where it's, more than 2. It's like don't hard code a value to just look for like 2 of a certain one. So it'll be, yeah, like the 3 case I kind of went through, right? So there's like 3 3s. So then that's a valid input for it. But I guess ideally, if you set your code up to handle the 2 case, it shouldn't be too hard to extend to 2 or more. I think maybe a challenging part of that would be when you get a bunch of like ties for whatever the current popular count is up to, right? I'll also type that here. for the after watchers. I mean, I say infinite. I think test case wise, maybe it caps out as like 5 or something, but definitely don't have like a hard coded value. But also too, if you are struggling with that and you can, definitely ask questions, of course, on how you might extend it. Um, but like if you did submit it with a case where you only had accounted for there being at most 2 of the same name, I would hopefully be able to give you feedback on how you could extend it, but it would technically not be like fully correct. But if you have questions on that kind of thing, let me know. And even if it's not right now during these office hours on Piazza, but again, if you do share like your code on Piazza, make sure it's a private post. Going back up here. Yeah, walking through this. So yeah, that should be a 15 for adding pairs. Since that's the largest sum, two numbers can make 8 and 7, right? Below are some example inputs. Okay. So if I look at this one, 9, 4, 7, 9, 3, 5, 10, so 10, and one of these nines is gonna be the largest because you can get the largest sum by adding the 2 largest numbers of the list. So basically what we're looking for is, so like looking for the 2 largest numbers in a list of numbers, right? Because with addition, you add the 2 biggest numbers, you get the biggest, resulting number that you can. So we're basically just looking for the 2 largest numbers in a list. So there's several ways you can do that, right? If when I do get a list, and we are talking about iteration still. We've learned about that previously, so maybe I want to like loop through each number in the list, looking for the biggest, right? You could then loop through again if you wanted for the second biggest. Or you could try like every combination, which might be inefficient. So if I'm just like looping through a list, then I might be like, oh, what's going on? There we go. Oh, it hates when I do that. Etc. Right? So you could do something like that because you want every combination. So it's kind of solutions, but maybe there's an easier way that maybe kind of uses something that we'll also want to use in find median to make things a little easier. But don't want to dive in too much. I feel like this is almost a giveaway too. But there's a pretty quick and efficient way to solve it as well. So if you don't make use of that, I think I'll probably just give that as a comment when grading the homework because it's not too much to type in. But yeah, that's adding pairs. Not to be confused with the fruit. So coin flip, again, this is like a 4-part function, but each function's body should not have like a large amount of code in it, ideally. And the main thing with this question is showing you how you can call functions from other functions and how it's really helpful in terms of debugging and writing the code and making the code readable when you kind of break a larger function down into smaller functions of like helper code, which some of you have already been doing in the code, which is fine. And again, definitely helps you in terms of readability and can with debugging. And I wanted to give some explicit experience with this, but we've been kind of calling these like methods and functions from other bits of code. As anytime we like do like print, we're calling like this print function from somewhere else. right? We're not like defining what the print function is within this function, so we're already kind of doing that. And you can think of that as the same thing. So, for instance, if I have like def function 1, we're going to call function 2, and then function 2, my print, here we go, right? So if I call function 1, then it goes to the body and it says, hey, let's call function 2, goes to function 2, prints, here we go. And so that's like equivalent. That is equiv to function to just calling print, here we go, right? So, and then if I have, just keep that there, I don't want to remove that example. So if we have like function 3, right? So x equals function 4, and then now we have function 4, then we return 5, right? What do you think print x will do in this case? Will x print, function 4? Will it print 5? Will it throw an error, etc.? So in this case, right, we call function 3, and it says, all right, well, we have this variable x, so we haven't, instantiated before. Let's make it, and we're gonna make it equal to, assign it to this function 4 call. And so then it's going to go down to function 4 and say, hey, what are we doing in here? And it says, hey, we're going to return this value of 5. And so it's like, okay, well, now x is just equal to 5. And so then when we print x, it prints this value of 5. And remember the whole print versus return thing, right? So it has to be returned. If you made this like print 5, it's not going to assign it the value of 5. So need the returns, and the returns are kind of already baked into these function body placeholders. So shouldn't have to worry about that. Yeah, it's I guess maybe a little more difficult to walk through the thinking process on these since there's like kind of small. But I'll just go off these comments that are fairly similar, right, to what's in here. Oh, my code's doing that thing where it gets cut off. This darn laptop. There we go. Well, hopefully I haven't been cut off this whole time. But we're just on coin flips now. So this should return a capital string H for heads or a capital T for tails with equal probability, like you're flipping a coin. Oh, I guess I will actually read this again, just to kind of explain the purpose of it. But so the odds of flipping a coin are roughly like 50-50 for heads and tails, right? So if I flip a coin, I expect like a roughly equal 50% chance for heads or tails. I know like the way a coin is designed, that's like maybe technically not the case, but it's basically 50-50, right? So statistically, if we flip 4 times, the odds of getting at least 2 heads is 11 out of 16, which translates as decimal. And so that's like kind of like Monte Carlo coin flip stuff if you're really curious. But yeah, so that's like a proven statistic. I didn't make this up. Right, so if we do 4 coin flips, 2 or more heads, it's this odds. So we are going to complete a series of 4 functions that help us test this, right? So you may think maybe initially, which I kind of did, was like, oh, if I flip a coin and I get 2 heads, 2 out of 4 that are heads, like why is that not just 50-50? Why is it, the statistic? So let's try it, right? So it's like, I don't want to in person, just keep flipping this coin and write it down. Like what I get and kind of prove it. We can actually like use code to do this, right? So like to simulate the flipping of a lot of coins, it's hopefully faster to write and definitely faster to run than it is to actually do this in person. So that's kind of what we're gonna do, right? So the 4 functions below work together with each function calling on the previous one. Comments are placed above each function detailing what they do, along with variables representative of something they might need to return. Note that none of these functions should be rather lengthy on their own. They should remain rather concise due to calling on the previous function. And I do think it's also the case where like coin flip should be the shortest, coin flips is second shortest, flip success third, and then resulting odds I think is maybe the longest, um, but not too long. But again, lines of code is kind of a garbage metric, so if your like coin flips is longer than your flip success, don't feel that you're immediately doing it wrong or anything. All right, so we need a yeah, something to like randomly return H or T half the time H and the other half T. So something to randomly do that 50% of the time. Yeah, I mean honestly, this is like kind of the thinking process, I guess. It's pretty short. Um, Coin flips. So let's see what this should do. This should return a list uh, of H and T's based on the above flip coin function, which is actually coin flip. The function being called the number of times corresponding to the input variable flips. Note this should call coin flips. All right. So I'd be like, I'm calling this somewhere. I'm doing this sometimes, right? And we have a list of H and T. And so I know coin flip, right, is going to return like an H or a T. And I have this list, so maybe that tells me I will need to like add the value of it to the list. Again, you could do something like this. And then I get this variable flips, and it's like call the below code flips amount of times, and then returns the list, right? And so in this case, maybe I'll pass in 4 for coin flips, and then I'll get a returning list that corresponds to the H's or the T's or the mix of them that would represent this statistic up here of at least 2 heads, right? All right, so we know we return a list. Let's, I guess, move on. So flip success, this should check if our results match the statistics, which means it needs to check if after 4 flips of a coin, we have 2 or more heads. Note this should call coin flips 4. All right. So yeah, I'm definitely just gonna go ahead and write that somewhere. And I know coin flips returns a list of H's and T's, and it'll have the amount that is correspondent to whatever's passed in. So if I'm passing in 4, um, then I'm gonna get like 4 H's and T's. So then maybe I'll get like that, right? And then needs to check if after these 4 flips, we have 2 or more heads. So my result would be this list, and now like, so then I need to check if, result says 2 or more of these H's, return true, and then, otherwise, let's return false. So it's maybe how I do that, right? Because it's a success here because we have 3 H's. Again, still a success because we have 2 H's. And this becomes a failure. So then this would return this false. Last but not least, resulting odds. This function takes in a number of trials to run the 4 coin flips on. Okay, it should do the 4 coin flips and record the results as a success or failure, depending on if there were 2 or more heads for each trial. All right. So if trial equals 100, then technically the coin should be flipped 400 times, with the results being taken every 4 flips. Note this should call flip success. So I get this number of trial count, which might be like 100. So let's do, then like 100 times, we call flip success. If we are successful, maybe increment the success count variable we conveniently have. Otherwise, do not. Then your trial count's already defined, the success count's already defined, and we've been incrementing it here. So yeah, then we would get our resulting odds to see if it actually matches up to this kind of decimal. And that's about it for kind of coin flip. And just kind of show you, we could have all this code right in this single function, but just to show you how you can like have a function call a different function, which calls a different function, which finally calls a different function, which might be useful for this upcoming homework, which I'm kind of still torn on if I want to almost like enforce the breaking up of code, because I think especially for PUI and for other more kind of prototypey code things you do, splitting up the code like this is so helpful. Even if you're writing a big function, right? You're like 100 lines in on the function. It's always nice to just be like, oh, this 30-line block could also be its own function. And just to make things readable so you don't scroll as much, debugging is easier. So, a lot of times you don't need all these other functions technically, but it does help with debugging, readability, and kind of code reuse. To sometimes, you have like for coin flip, maybe we have a different coin trial we need to do or whatever to try the different odds, like the odds of getting 8 heads or something. So we could just call this coin flips function again as opposed to rewriting the code. So it also helps for reusability. But yeah, I think that's all for the homework. We covered the lab already. Piazza should be up to date with everything. Again, an announcement coming soon, tonight or tomorrow, about the lab homework and quiz. Quiz will be a little different. Definitely will be providing 2 kind of other helpful resources that deal with recursion, which is one of those things where like you might not use it that much in practice, but it's a nice computational thinking thing to have. Um, and you will probably encounter it, but like you won't be writing probably like recursive functions all the time, right? Um, yeah, looking forward to that. Hopefully it's not too bad. I know recursion is kind of also a big topic that a lot of students struggle with. Um, so with that in mind, I'm trying to make this kind of lab quiz around it a little more worked example, kind of scaffolded, right? Because I think for how long often courses spend on this topic, that you don't see it as much in the wild as like a course would lead you to believe. That being said, though, it's still super beneficial to like your computational thinking, and you will probably encounter it at some point. So that's kind of why it's also in intro classes, and it makes use of the other concepts we learn too. So I'm not trying to like downsell it, but I think like the time we're going over is an appropriate amount, and the depth we'll go into it is an appropriate amount, which also kind of means like it's easier lab quiz for you. So I guess it's a win. Yeah, I'll send that announcement out. I will still be pretty active on Piazza this week. I'm leaving tomorrow, and I'm gone till like Saturday, so I will have the more lower quality kind of office hours, as I'll just have my single laptop. And again, the times will be shifted from the usual, but I'll try to mimic last week's, which still had, I guess, like the usual amount of attendance for them, and no one complained. So hopefully this week's adjusted times being the same, we'll do the same kind of thing. And I'll be cognizant of the cutting off at the bottom of the screen that this laptop does, which isn't bad actually. It's like maybe a fifth of it, but and they'll all be recorded and whatnot. Yeah, so I guess that's it. Post on Piazza or email me or something if you have questions. Hope everyone's doing the homework. Uh, have a couple submissions already, which is good. Um, Tomorrow morning, right before the homework is due, I don't think I'll have internet. So hopefully I don't miss too many questions during that time. Um, but I guess around 10 a.m. EST I'll be able to check, or 9 a.m. EST. But hopefully you're not waiting till 3 hours before the homework is due to do it. But I know life gets in the way, and that's why you have flex days too. So feel free to use those if needed. But otherwise, yeah, post on Piazza, and good luck with everything. Hope everyone had a nice weekend, and we just have 2 more weeks left of the course. Then you'll be in Pittsburgh if you're not already at Carnegie Mellon doing your masters. Time flies.